Hi, in this video I'll go over to solve a few questions on the assignments for 2.3 and 2.4 as a few of you requested me to solve for that. Now let's go over the first one, question 6 on 2.3. In this case, we are solving for the value of x, which makes the f of x equal to x. Okay, let me just copy this question to the Word, and then we can do it from here. Okay, so we are solving for the value of x, which makes f of x equal x. So this is the requirement. F of x is minus 1/2 x plus 3, right? This is f of x equal x. So let's put that x. Now we're just solving the value of x. So in fact, we are just solving for x of this equation. And because this is the equation with the fraction, so the best way I can do is I multiply both sides by the LCD, because I don't want to deal with fraction. So anytime you see fraction, go ahead and multiply the left side and the right side by the LCD. In this case, the LCD is 2, because you can see there's the 2 here and 1 here, so the common factor, the least common denominator should be 2, right? So I multiply by 2 on both sides. If you do something on one side, make sure do the same thing to the other side. And now do the distribution of that. 2 to here, so 2 to here, the 2 will cancel out. So you have minus 1 times x. 2 times 3, which becomes plus 6. 2 times 2 is 2x. Now let's just move the x on one side. So this is minus 1x, so I add 1x on both sides. Then I get 6 equal 2x plus x, 3x, and then divide both sides by 3. So x becomes 6 divided by 3, which is 2. So 2 is the value of x. That makes this requirement to be true. Back here, the answer should be 2. Good. Okay, there's a few questions on section 2.4. Let's try one of these questions here. This is the composite function, and many of you have problem for this one, so I'll go over it now. Okay, let's move it here. Let me paste the question to the next page so we can work on that. Okay, cool. Let's do it here. So we are given the two functions f and g. We are asked to find the composites of f and g, or g and f. Let's try maybe example A in this case. So the f composites with g of x means f is the outside function and g is the inside function. So this is the definition that we saw in the class, right? Now we know that the inside function is g of x, but g of x is x minus 5. So we just go ahead and plug in x minus 5. Okay? So at the end, you are just finding what is the value of f of x minus 5. Okay, we don't have the formula for the function f when the argument is x minus 5. But we do know that f of x is given as x squared. That means anytime you see x that Anywhere you see x, it's just x, and the square is the power of that x. And now the new function f of x minus phi. So anywhere you see x in the original formula now become x minus phi. So according to our old formula, we use that to get our new formula f of x minus phi. In fact, anywhere you see x in the old formula now become x minus phi. So x minus phi and then square, because x is the old formula, but x now become x minus phi in the new formula. Now to simplify this one, you need to expand it out. And to do this, we know that the square power means x minus phi times x minus phi 2 times. And now just do the FOIL method. X times x times phi. X times x is x squared. X times minus phi x, minus phi times x, minus phi x, minus phi times minus phi plus 25. Combine them together, combine like term, minus phi x minus phi x, give me minus 10x, and carry down x squared, and then plus 25. So x squared minus 10x plus 25 is the answer for A. So x squared minus 10x plus 25. Okay. I would like you to do B by yourself. Now we can also try C. So C, we are given a natural value for the argument. So again, f composites with g when the value of x is minus 1. The same thing, f is the outside function, g is the inside function. In this case, we have the real value minus 1. So all you do now is you need to figure out what is g of minus 1. Right? What is g of minus 1? We know that g of x is this here. So g of minus 1. So anyway you see x, that's become minus 1 in function g. So x minus 1 minus 5, which become minus 6. So g of minus 1 is minus 6. So in here, this whole thing become minus 6. And now you just find the value of the function f when x is minus 6. The function f was given f of x equal x squared. Okay? So f of x equal x squared. F of minus 6, which equal to minus 6 squared. Because anywhere you see x, now become minus 6. Minus 6 squared means minus 6 times minus 6. 6 times 6 is 36. Minus 10 minus become plus. So the answer here is plus 36. Okay, I skipped the 2 problem here, and I'll let you try that on your own. That's why I got half points. Okay, the next question. 10. Again, they ask you find the value of x when function f of x equal to x. We are given this is the function f of x. Now the requirement is that this function is equal x. So all you do now is you set the expression 3x plus 6 equal to x, and then we solve that equation for x, and that should be the answer here. The next question, 11. Okay, this is a word problem. A company manufactures and sells the DVD. Here's the equation they use in connection with their business. The number of the DVDs sold each day, n of x equal x, selling the price for each DVD, p of x, which is this one. So n, the number, p, the price. The daily fixed cost 210. The daily variable cost 2x. Now they ask you to find the following functions. Okay, let me copy this one into the Word, and we can do it from there. Right, let's do it here. Okay. So part A. We are asked to find the revenues, which is the product of the number of the DVDs sold each day and the selling of the price. So the revenues is defined as the product of the number of the DVDs sold each day. The product means multiplication. The product of what? Of the number of the DVDs sold each day and the selling price. The number of the DVDs sold each day is X. Right, the number is X. The product means multiplication. And it's selling the price. Selling price is this one, which is 7.5 minus 0.07 X. And then all you do now is you simplify. Always we have to simplify the expression. So multiply this one in, multiply that one in. That should be the final answer. So whatever you get here should be the answer in here. The fixed cost, the cost here is the sum of the fixed cost and the variable cost. The fixed cost is just the cost that you have to pay no matter if you are selling 0 product or 1,000 product. The fixed cost is just the cost that you have to pay monthly, no matter how many product you are selling. You have to pay that anyway. So the fixed cost is just there. It's independent of the number of the products. So the fixed cost in this case 210. So they say that the total cost is the sum of the fixed cost. The sum, which is the plus between the fixed cost, which is 210, and the variable cost. The variable cost is 2x. So that should be the fixed cost, the total cost. Now the next one, profits. The profits is a different. The difference here is a subtraction. So the difference between the revenues, which is anything that you get here, bring it down here, and the cost. So anything you get here, bring it down here, and do the subtraction, and then simplify them. So that is the profits. And then the last one, the average cost, is a quotient. Quotient is the division, right? The quotient. The quotient of the cost, which is the one that you found in part C, right? This stuff here, the quotient, and the number of the DVDs sold each day, which is X. So that expression here divided by X, and then make sure you simplify it. So that's the general idea of how you solve this problem, and I'll let you to try that on your own. The next question that I have here is 12. Okay, this is a good another word problem. Let me copy that and we go to the Word document. Okay, we do it here. Okay, so they say that use the following formulas to answer the questions. T of m comma r equal to r plus 0.6 m minus r, m of x equal to 20 minus x. R is the resting heart rate, m is the maximum heart rate, and x is the age of the person. Now recall that our discussion of the heart rate and composition of functions from the end of the section 2.4. Find the training heart rate function T of m for a person with a resting heart rate of 60 beats per minute. Then find the following. Okay, so we will go slowly, step by step, A, B, C, D here. So find the maximum heart rate function m of x for a person x years of age. Okay, So we are finding the maximum m of x, but we already given that one, right? M of x equal to 220 minus x, and x is the number of the years of age. Now this is the function for the maximum heart rate function given here. What is the maximum heart rate for a 30 years old person? So this is the years of age, 30, which is x, right? So you want to find the maximum heart rate, we have to use a maximum heart rate function right here. So you are looking for the maximum heart rate of a person of 30 years old, or 30 is the x, because 30 is the age. So 30 m 30 for part B. So using the formula, anywhere you see x now become 30. So 220 subtract 30 should be 190. Okay, so 190 beats per minute. Now what is the training heart rate for the training heart rate for a 30 years old person with a resting heart rate of 60 beats per minute? Okay, so now you are looking for the training heart rate. This is the formula for the training heart rate. This is the maximum heart rate, the m. T stands for the training, the heart rate. So we are looking for the training heart rate, which is the T. Okay, now this person is 30 years old of age, and he or she has a 60 beats per minute for the resting. So this person here has the he or she is 30 years old. So we know that the m of 30 should be 190. The maximum of heart rate is 190, and then the resting heart rate should be 60. So m should be 190. The maximum heart rate is 190. The resting heart rate is 60. It's given from here. So what should be the training heart rate? The training heart rate depends on two things: the resting heart rate and the maximum heart rate. So we already have the formula, so just use that. So that equal to r in this case 60 plus 0.6. The maximum heart rate for this person is 190. The resting heart rate again 60. So do the calculation. You should end up with, let me do that for quick. 190 subtract that, multiply by 0.6, and add to 60. It should be 138. So 138 for part C. Now the next one, they ask you the same thing. What is the training heart rate? In this case, the only thing that different from here, from B and C, D and C, is that this person now is 42 years old. This person still has the resting heart rate R to be 60, but the M, the maximum heart rate, is no longer 190 because the age is changing. And to find the M of 42, you have to use this formula again, because this is the formula for the M. So plug in 42 for X, find what is the maximum heart rate. Once you get that, combining with the R to be 60 in this formula for the training heart rate, and then figure out the rate. And then the same thing for the last part E. Once you figure out C, then you should be able to do D and E. Okay, so I will give you the hint for that, and you can practice on solving the rest of the problem. Okay, the last example here I have for you for section 2.4. One of the problems with alternative energy production is the relatively high cost associated with renewable sources. For example, in 2009, the cost per megawatts hour for conventional coals was $94.90, while that of the wind was 98.20. Now let's X represents the megawatts hours of production. Create a function of the cost of the coal and the cost of the winds. Okay, so let's copy that, and then I'll go here. We do the problem in words. Okay, for some reason the Word document is not working, so I'm using the painting tool here. So they ask you to find the cost of the coal production. So C of X, this is the cost. So X is what? X is the hours, right? If X represents the megawatts hours of production. Now they ask you to create a function for the cost of that. So depending on how you spend the megawatts hour, if you spend more of that, you have the cost is more. In this case, we know that the cost per megawatts hour for the coals was 94.90. That means for each of the megawatts hour, it takes you 94.90. So the cost for that is 94.90 of X, or multiply by X. Because if you just spend 1 megawatts hour, then it takes you this much money. If you spend 2, then you multiply that by 2, or 3 by 3, and so on. And then the wind, the same thing. W of X, we know that the cost for the wind, the cost per megawatts hour is 98.20 for each. So 98.20, just multiply by X to get you the cost for the wind. Because if you spend more, then you have to pay more. X is the number of the megawatts hours. And they ask you to find a function representing the increased cost of the wind as compared with the coals. Now you see that the wind is 98.20 each, so it's higher. It's not that big difference, but it's higher than the coals. So in this case, to find the increasing cost between C and W, that means you just find the difference in the cost between C and W. We take the higher value, the cost, subtract the lower one, and that should give me the difference, or it tells you, in other words, the increased cost of the winds as compared with the coals. And the same thing, right? You take the higher, subtract that, and if I plug that in here, I should get the final answer. Okay, so that's some problem for section 2.3 and 2.4, and I hope that will help you on the assignments of this week. And thanks for watching.